So now that we've talked about factors and prime factorizations of numbers, let's talk about how to write fractions in simplest form. And we're going to use what we just learned to do that. Before we talk about simplest form, let's define an equivalent fraction. So two fractions are said to be equivalent if both fractions represent the same portion of the whole. So here's an example. Let's say we have this picture right here in which we break it up into thirds, and we are representing 1/3 of the fraction. So here's 1/3 of this three-piece stick. We can also write this as something that's separated into 6 pieces. And if we shade 2 of the pieces, here we're representing 2/6 of the whole. In both of these cases, I'm representing the same portion. I'm representing the 1/3 of the whole thing. But only this one right here, the 1/3, only that is called the simplest form. So, in short, or in definition, a fraction is written in simplest form or some people also call it lowest terms, when the numerator and the denominator have no common factors. Other than 1. So let me talk about what I mean by that. Visually, simplest form just means that I am shading only one piece. That I cannot simplify this as shading a larger number of pieces. So what we're going to do is we're going to use some of the rules that we already know. So for example, the fraction 2/6, which we talked about up there, let's see if we can write the 2 and the 6 as a product of factors. So 2 is nothing more than just 2 times 1, or just 2. 6 I can rewrite as 2 and 3. So because the 2's are in common to both the top and the bottom, I can cancel them out. And what I'm left with is I'm left with a 1/3. So what we did here was we simplified the fraction because it had factors in the top and the bottom of the fraction that were in common. What we're doing is we're using a couple of properties. One of the properties we're using is that if you have any number over itself, that simplifies out to be 1. And that's what we did over here. When we had 2 over itself, we simplified that to be 1. So this is just a 1 times a 1/3, which is just a 1/3. We're also going to use the property that says if you have A times C over B times D, we can rewrite this as A over B times C over D. And we'll talk a little bit more about where this rule comes from. But we're using that rule to say, okay, if we had 2 times 1 over 2 times 3, we can rewrite this as 2 over 2 times 1 over 3. We know the 2 over 2 is 1, so I am left with just a 1/3. So we're going to use these properties in order to simplify fractions. So let's talk about simplifying fractions. So let's say we want to simplify the following. And by simplify, I mean write in lowest terms, or in simplest form. So say I want to write 4/6 in simplest form. What I'm going to do, my first step is going to be to find the prime factors of 4 and find the prime factors of 6. We just did this, but let me just go ahead and do it on the side. Prime factors of 4 are 2 and 2. Prime factors of 6 are 2 and 3. So I'm going to rewrite 4 as 2 times 2, and I'm going to rewrite 6 as 2 times 3. Then, because I know that this 2 over 2 is going to be 1, I can just cancel them out with each other. And then what I'm left with is 2/3. So 4/6 simplifies out to be 2/3. I use the properties up above to break them up, divide factors into each other. So let's try another one. Let's write the following in simplest form. 30 over 45. So my first step is to find the prime factors of 30. So let's do that. 30 breaks up into 6 and 5. 5 is prime, but 6 is not. 6 breaks up into 2 and 3. And again, I know I started with 3 and 5, but you don't have to. You can start with whatever factors you want. You're going to end up with the same prime factorization, which is 2 times 3 times 5. Now let's find the prime factors of 45. Well, 45 breaks up into 9 and 5. 5 is prime, but 9 is not. 9 breaks up into 3 and 3. These are both prime, so I can stop there. So the prime factors of 45 are 3, 3, and 5. So now what I'm going to do is I'm going to identify any factors that I have in both the top and the bottom, and I can cancel them out. So I can cancel out these 3's, and I can cancel out these 5's, and I'm left with 2/3. Okay, let's try one with variables. Let's try 39x over 51. Okay, so I have to find prime factors of 39. And if you use your divisibility test, you will find out that one of the divisibility tests says that if the sum of the digits is divisible by 3, the number is divisible by 3. So here 39 sums up, 3 and 9 sums up to 12, which is divisible by 3. So 39 is divisible by 3. 39 actually breaks up into 3 and 13, both of which are prime. So I'm going to write 39 as 3 times 13, and the x is just going to kind of hang out there. And now let's talk about 51. Well, 51, we have to find factors of 51. And again, you can add up the digits. 5 and 1 add up to 6. 6 is divisible by 3, so the whole thing must be divisible by 3. So it actually turns out that 51 is divisible into 17 and 3, both of which are prime. And now I'm just going to cancel out any like terms in the top and the bottom, any like factors. So I have the 3's are like factors and everything else has to stay. So the simplified form is 13x over 17. Let me do one with negatives, and then I'll give you a bunch for you to try out. So let's try negative 9 over 50. So with the negatives, what we're going to do is we're going to leave the negative out front and just find the prime factors of 9 and the prime factors of 50. Prime factors of 9 are 3 and 3. Prime factors of 50, well, 50 breaks up into 5 and 10 breaks up into 2 and 5. So the prime factors of 50 are 2, 5, and 5. So notice something interesting happen here in that there are no common factors in the numerator and the denominator. So what's going to happen is this fraction doesn't simplify. It's already simplified. So my simplified fraction is just negative 9 over 50, the same thing I started up with. Here are some sample problems for you to try out. Try simplifying 49 over 112, negative 64 over 20, and 7a cubed over 56a squared. Now let me start this one out for you, but it should be fairly easy. So one thing you should keep in mind is a cubed is the same thing as a times a times a. And 56 breaks up into 7 and 8, and 8 breaks up into 2 and 4, and 4 breaks up into 2 and 2. So 56 is the same thing as 2 times 2 times 2 times 7, and then I have an a squared, which is nothing more than a times a. Once you have this, you can start canceling out common factors, and keep in mind that the variables are also common factors. So that's how to simplify fractions. A different thing you might be asked is, are two fractions equivalent? So let's look at that question. Are two fractions equivalent? And one way to figure this out is if they both simplify to the same thing when converted to simplest form. So there are two methods. Method one is going to be simplify them both, they're equivalent if they're the same fraction. And here's what I mean by that. Let's say that I want to figure out if 16 over 40 is the same thing as 10 over 25. Well, what I'm going to do is I'm just going to simplify these. So 16 breaks up into, let me do it on the side, 4 and 4, and each one of these 4s breaks up into 2 and 2. So 16 is the same thing as 2 times 2 times 2 times 2. 40 breaks up into 4 and 10. 4 breaks up into 2 and 2, and 10 breaks up into 2 and 5. So 40 is 2 times 2 times 2 times 5. Then let me just cancel out my numerator and denominator, so I can cancel out these 2's, these 2's, and these 2's, and I'm left with the 2 over 5. Now I'm done with the left side. Let's simplify the right side. Well, 10 breaks up into 2 and 5, and 25 breaks up into 5 and 5. Do you see any factors in the numerator and the denominator that are the same? And you should. These two 5's are the same. So what I'm left with is I'm left with 2 over 5. These two fractions are the same, so I know that yes, they're equivalent. So it turned out that 16 over 40 and 10 over 25 were really the same fraction. There's another method, I'm going to call this method 2, and that's by cross products. And the cross product says, okay, let's say we have the same problem, 16 over 40 and 10 over 25, and you're trying to find if these two are the same. The cross product says, okay, if you cross multiply across the equal sign, so 16 over 25 on the left, or 16 times 25 on the left, leave the equal sign in there and then see if 40 times 10. If these two multiplications give you the same answer, then these fractions are equivalent. 16 times 25 is 400. 40 times 10 is also 400. Because these two are the same, I know that yes, they're equivalent. So it's pretty easy to check for equivalency, and you have two ways to do it. So what I'm going to do is I'm going to give you one more example, and you can do it whichever way you want. So figure out if the following are equivalent. So we're going to do 4 over 13. We're trying to figure out if this is the same thing as 5 over 18. So go ahead and try that one.